Hello, welcome to Smart Minds Learning, where learning is easy and fun. In today's class, I have an interesting topic to teach you, and we shall be looking at calculus. Now, I'm going to break up this calculus into separate videos. In this video, we'll be focusing on differentiation. So I'll be teaching you how to differentiate from the basic. Alright, so please stay tuned and stay till the end of this video. Please stay tuned till the end of the video and ask questions at any point you are confused or you are lost. Alright, I'll be answering every question you drop. Okay, now let's move into the video. What is differentiation? Differentiation is the process of finding the gradient function of an expression. Whenever you have an expression in x, that expression, we can actually differentiate the expression. Alright, so the symbol for representing the gradient function of that expression is given to be dy by dx, popularly called dy dx. So anyone that suits you, you can use it. So you can call it dy dx or dy by dx. So dy by dx is the notation used for the gradient, and it simply means the rate of change of y with respect to x. It simply means the rate of change of y with respect to x. Alright, now let's quickly take a look at the formula to use whenever you want to differentiate an expression in x. So the first part of the formula is if y equals n raised power x raised power n, then dy dx equals to n x raised power n minus 1. This simply means that you are multiplying the power n by the coefficient of x, which is 1 in this case, right? Then you subtract 1 from the power. Remember, you are only doing two things basically. You multiply the power by the coefficient of x, which is 1 in this case, then you subtract 1 from the power. Okay, also if the coefficient of x is not 1, maybe any other number apart from 1, then you are going to apply it in this form. So if y equals a x raised power n, then dy dx is given to be, now you multiply n by a is the power, is the coefficient of x rather, and here the coefficient is not 1, it can be any other number apart from 1. So you multiply n by a and you have an, then you subtract 1 from the power. Remember, you are only doing two basic things: multiply the power by the coefficient, then after you do that, you subtract 1 from the power. Okay, please do not forget that, always remember that. However, differential coefficient can also be given by f prime of x, that is dy dx. That means sometimes you don't write it as dy dx, you can also write it as f prime of x. Now let's quickly take a look at some other rules in differentiation that we use. So the first one is chain rule. Now chain rule is used when y is a function of u, when y is a function of u, right, and u in turn is a function of x. I repeat, chain rule is used when y is a function of u and u is a function of x. So the formula is dy by dx equals to dy by du times du by dx. All right, and this formula is also known as composite rule, okay, or function of function. So I'll be solving some questions and I'm going to apply this chain rule. I will tell you when to use chain rule. Okay, the next rule I want you to take note of also under calculus differentiation is the product rule, and product rule is given in this format. If y equals uv, that is you are multiplying two functions, that is y is a function of two separate items, u and v. So where u and v are functions in x. All right, so the formula to use for product rule is dy by dx equals u dv by dx plus v du by dx. Please take note of this formula. And lastly, for quotient rule, the formula to use is if y equals u over v, you can see that quotient rule is unlike product rule. So product rule is like you are multiplying the function of what y, which is given as u and v, the product of two functions u and v. But in quotient rule, we are given the function of y as two separate functions, but in this case we're having them in fraction format, or you are dividing them. So where u and v are functions in x, then dy by dx equals to v du by dx minus u dv by dx all over v square. But take note, v is not 0. When v is 0, then you can't apply this formula. You can only apply this formula when v is not equals to 0. Now let's take a look at some examples, and I'll be applying the chain rule, the product rule, and the quotient rules respectively. Alright, so the first question here is, if y equals 4x raised to power 2 minus 3x, differentiate y with respect to x. Now when you look at this question carefully, the first thing you want to look at is, are there x in this expression? Of course there are x's in this question, so we have this expression is given in x. So we are going to consider each of these terms separately and we differentiate them. So the first term here is 4x squared. So by differentiating 4x squared, I'm going to multiply the power 2 by 4, which is the coefficient, and that gives me 8. Then subtract 1 from the power, which is 2 minus 1, and that gives me 1, right? Then you move on to the second term. We have minus 3x. If you look at this carefully, there is invisible 1 here. So multiply the invisible 1 by minus 3, which is the coefficient. We have minus 3. Subtract 1 from the power 1, like this, and we have 0 left. So remember, any number raised to power 0 is what? 1. So 1 times minus 3 is still minus 3, and 8x raised to power 1 is still what? 8x. So the final answer for differentiating this expression is 8x minus 3. Here is another example, and here we are asked to differentiate the following with respect to x. So the first question, y equals 5 root x, and the second question, f of x equals to 8x plus 1 all over root of x raised to power 5 plus 9. So let's focus on the first part. Now we have y equals to 5 root x. Now if you look at this, we need to rewrite this expression so that x can take a power, and that's how to apply your general formula of differentiation. Okay, so if x does not have any power, then we can't differentiate. So I need to rewrite this square root of x as x raised to power 1 over 2. Remember, from the law of indices or surds, we can, whenever we have roots and a radical, you can write it as powers, all right, depending on what the roots is. So here we have square roots, so that becomes power of 1 over 2. Assuming we have cubed roots, that will become power of 1 over 3. If we have fourth roots, that will become power of 1 over 4, and so on and so forth. All right, so by rewriting this expression, I have 5x raised to power 1 over 2. Now let's differentiate now. So the first thing we want to do is multiplying the power by 5 coefficients. So half multiplied by coefficient 5, that gives us 5 over 2. Then remember, you subtract 1 from the power. So half minus 1, that gives us negative 1 over 2. And remember, in mathematics, when you have a negative power, you need to rewrite it as the reciprocal of the variable. So the reciprocal of x is 1 over x. But remember, we have power of half, that will be written as what? The square root. Okay, remember, I've changed the square root to power half, but finally in my answer I need to return it back to its radical form, right? So we have 5 times 1, which is 5, and 2 times root x, which is what? 2 root x. Okay, please take note of that. Now the second part of the question, we have f of x equals to 8x plus 1 over root of x raised to power 5 plus 9. So like I told you, this expression, we need to rewrite it. So by rewriting this expression, we are going to have it as x raised to power minus 5 over 2. Going further in the explanation, so after we have rewritten the expression, then we can now differentiate. Remember, we have f prime of x to mean the same as dy dx. So the power of invisible 1 multiplied by 8, that gives us 8 times 1. Subtract 1 from it. Then we have x raised power minus 5 over 2. So that's minus 5 over 2 multiplied by invisible 1. That becomes minus 5 over 2. Then subtract 1 from the power, which is minus 5 over 2 minus 1. Then remember, we have a constant. So whenever you have a constant and you differentiate a constant, it becomes 0. So we have 9 in the question. So when you differentiate 9, it becomes 0. Whenever you differentiate any constant, when there is no x related to the number, it becomes 0. Okay, so moving forward, we have 8 times 1, which is 8. Power 1 minus 1, that's power 0. Then bringing out this, okay, then minus 5 over 2 minus 1, that gives us minus 7 over 2. Then bringing out this. So all we just need to do is to simplify this expression and get our final answer. So 8 times x raised power 0. Remember, any number raised power 0 is 1. So 8 times 1, which is 8. Then bringing down this expression, then 0 leaves the equation. Okay. Now the only thing we want to do here is to rewrite x raised power minus 7 over 2. When you rewrite x raised power minus 7 over 2, it becomes 1 over the square root of x raised power 7. I've explained this in the previous examples. Alright, so 5 times 1 is 5, then 2 times the square root of x raised power 7 is this. So final answer is 8 minus 5 all over 2 roots x raised power 5. Please take note, this is not square root. This is 2 as the coefficient of the square root of x raised to power 7. Right? Now this next question is to apply the chain rule formula. Okay, so you can see that y is given as a single expression and it is composite. It is composite in nature, especially the denominator. So when you have composite function, any function that looks like this on the denominator is composite, right? So when you have composite function, you use your chain rule. Okay, or when the question is in this format, just take note of this question. Whenever the question is in this format, you have to use chain rule. Why? Because y is given as a function of u and u is as a function of x. Okay, so the solution to the first part of the question, we have y equals 5 all over open bracket 7 minus x raised to power 3 all raised to power 4, right? So the first thing we want to do is to rewrite the expression as a single term with a power. So all I just have to do is bring down this 5, then I'm going to have 1 on the numerator, then that 1 on the numerator changes to negative power, right, for this denominator. So that's how to rewrite. So by rewriting this expression, we have this. Okay, now let's bring in u into this expression now. So wherever you have this bracket, let u represent everything in this bracket. Okay, so let u equals 7 minus x raised to power 3. So remove this 7 minus x raised to power 3 and put u there. That becomes y equals to 5u raised to power minus 4 as we have it here, right? So let's differentiate u with respect to x. Now when you differentiate u with respect to x, all you just have to do is, this is u, right? So wherever you have anything related to x, you use the general formula. All right, so 7 does not have x, so it is a constant and it becomes 0. So 7 leaves this expression. So let's focus on negative x raised to power 3. So remember, 3 multiplies the power of negative coefficient here. I repeat, 3 multiplies the negative coefficient we have here. So 3 times minus 1 is minus 3, then 3 minus 1 is 2. Alright, so du dx is given to be what? Minus 3 x raised to power 2. So I have differentiated u. Now I need to differentiate y with respect to u. Remember, the first thing to do is differentiate u with respect to x. This is u with respect to x. I differentiate it. Now I need to differentiate y with respect to u. Okay, so we have the power minus 4. So just like we have been doing since, minus 4 times 5 is minus 20, right? Then when you subtract 1 from minus 4, that gives us minus 5. Okay, so dy du is minus 20 u raised to power minus 5. Okay, now moving down to the solution, we can now bring in the chain rule formula. So the chain rule formula is given by dy dx equals dy du times du dx, right? So when you substitute all the variables, all the parameters we have obtained, so the first parameter is dy du, which is this. So dy du, I bring it in here, right? Then the next thing in the formula is du dx. Du dx is given by this, right? So you bring it and multiply the 2. So you have to be very careful here so you don't make mistake. So the first thing I want to multiply are the two coefficients. So minus 20 times minus 3 is 60. Then you bring x squared and u raised to power minus 5. Bring them together. Now u needs to leave this equation because it is not part of the original question, but we brought it in order to apply the chain rule. So I need to remove u and replace it with its original value, right? So recall u equals to what? 7 minus x raised to power 3. So I need to bring in u, that value for u back. So if you look at this place very well, the only thing that leaves this equation is u, and I bring in what? 7 minus x raised to power 3. Every other thing remains the same. Now because the power is negative, you need to return it back to the fraction state. So 60x raised to power 2 multiplied by 1 on the numerator, that gives us 60s squared all over, then every other number goes to the denominator. Alright, so minus should leave this expression. So that will be 60x squared all over, open bracket, 7 minus x raised to power 3 all raised to power 5. Take note of it, all raised to power 5. No more negative sign there. Alright, here is the solution to the second part of the question under chain rule. Okay, so we have y equals to 1 all over the cubed root of 5x squared plus 3x minus 2. So you can see, don't be scared by how the expression look like. So remember, we have been doing something since morning, which is rewriting the expression, and I've told you various ways you can rewrite. So the first thing I want to rewrite here is this cubed root rather. So cube root changes to power of 1 over 3. Remember I mentioned it in the previous examples. Now we have 1 on the numerator, and that 1 on the numerator changes to a negative sign for the power. So I'm applying the laws of indices or sorts as it applies to these questions. Alright, now I've rewritten the expression. Now we can differentiate using chain rule. Before now I can't differentiate until I rewrite it. Okay, so now that I've rewritten it, then I let u represent everything we have in the bracket. So what are numbers in bracket? 5x squared plus 3x minus 2. Alright, so I need to bring in u, so that becomes y equals u raised to power minus 1 over 3. Okay, now the first thing we want to do is to differentiate u with respect to x. So let's differentiate u with respect to x, and that will be done from here. So from here, everything we have here we differentiate. Alright, so the first thing is 5x squared. When you differentiate 5x squared, it becomes 10x, right? Then when you differentiate 3x, it becomes 3. Remember the whole process of differentiating. I've explained it in the previous examples. Alright, now this is a constant value, and remember when you differentiate a constant value, it changes to 0. So this leaves the equation. That's why I did not write anything there. Alright, so I've differentiated u with respect to x. Now let's differentiate y with respect to u from here. Okay, so from this point, the power we have here is minus 1 over 3. So minus 1 over 3 times the invisible 1 becomes minus 1 over 3. Then subtract 1 from this power, it gives us minus 4 over 3. You can quickly do this on your calculator. Alright, now let's move further. When you bring in the formula for chain rule and you substitute each of the values, alright, so we have the value of dy du is minus everything here, right? So the value of dy du is this, so substitute it straight up, then multiply by the values for du dx, right, as we have it here. Moving further in the solution, so having substituted the values for the parameters in the formula, all you just have to do is simplify to the simplest form. Alright, so the first thing I'm going to do is remove this negative power from here, right, and by so doing this entire number becomes a fraction. So remember, we have a minus sign for the coefficient, but this time around 3 is coming down to the denominator, so 3 times u is 3u with power of what, 4 raised to power 3. Then this 1 goes to the numerator, or you can say this minus power, negative power, has turned to 1 on the numerator. Alright, then on this side, bring down what we have there. Then you multiply this bracket by 1 and it comes to the numerator, right? The denominator remains the same. Now remember, we need to remove u from the whole expression because it was not part of the question. So remember that we represented u by the terms in the bracket before, so let's bring them back now. Alright, so u is leaving this expression and all the terms in the bracket returns, so we still have 3 there and the power is still there. The only thing that changed was the expressions represented by u. Alright, so this is the final answer, minus 10x plus 1 all over 3 into bracket 5x squared plus 3x minus 2 all raised to power 4 over 3. Alright, now let's quickly take a look at a question so that we can, understand how to solve product rule. Okay, remember what I told you about product rule. Product rule, we are having y as a function of u and v, right, and u and v are multiplying themselves. Okay, so here is the question we have here, and want to apply the product rule. So we have y equals bracket 2x minus 1 close bracket open bracket 3x minus 2 close bracket raised to power 5. Now let's look at how to solve this interesting question. So the first thing to do is let u and v represent each of the terms in the bracket, and they are, because these two terms are multiplying themselves, so let y equals to uv. Remember, product, so u is representing the first bracket, v is representing the second bracket. Okay, now let us differentiate u and v respectively. So we have u represented by what, 2x minus 1, and we have v represented by bracket 3x minus 2 all raised to power 5. So let's differentiate u with respect to x. By differentiating u with respect to x, we have, remember, x has a power of 1 here, so 1 times 2 is 2. Then when we remove 1 from 1, that becomes power 0. Any number raised to power 0 is 1, so 2 times power x raised to power 0 is still 2. Okay, now minus 1 is a constant term, so when you differentiate, it leaves the equation. Alright, now let's differentiate v with respect to x. So if you look at v is a composite function, and there's a shortcut for differentiating a composite function. Instead of following the whole process of chain rule again here, so there's a shortcut for that. And what is the shortcut? You are going to differentiate the entire expression as a single term. So when we differentiate this entire expression as a single term, just like having 5 as the power, so 5 multiplied by invisible 1 is still 5, Abby, right? Then 5 minus 1 is 4. Do you see here? So everything here is seen as a single term, right? So I've differentiated the outer expression, everything all together. Now let's differentiate the inner expression. We have 3x minus 2 in the bracket. So when you differentiate what we have in the bracket, you are only going to have 3, because 1 times 3 is 3. When we remove 1, we have x raised to power 0, which is still 1. So 3 times 1 is 3. So the shortcut for differentiating a composite function is you have to find the differentiate the inner expression and differentiate the outer expression, then you multiply them together. So that is what I've just shown you here. So I differentiated the outer expression, everything all together, and I have 5 brackets 3x minus 2 all raised to power 4 using the general formula of differentiation. Then when you differentiate the inner expression, I have 3x minus 2. So the inner expression, when you differentiate, we have only 3, but you are multiplying them together. So multiplying the differentiation of what? The internal term and the outer term, and you multiply them together. So let's go. So 3 times 5 is 15, and everything still remains the same. So I've differentiated v with respect to x. All right, please take a look at it carefully. If you did not understand how I did it, please drop your question. All right, or you can watch the video again. You can just rewind the video, you can pause it and try it yourself. Okay, all right, now let's move on. So stating the formula for product rule, here is the formula for product rule. All right, so each of the parameters, we can now substitute their values there. So the first thing in the formula is u, and what's the value of u? U is given to be what? 2x minus 1, which is this. Then followed by dv dx. dv dx is everything we have here, right? So bring it here. All right, so I've substituted these two, right? Then plus. Then the next thing we have is what? V. So v is everything we have here, so I brought it here. Then times du dx. Remember, du dx is 2, right? From here. All right, so let's proceed. Let's move further. So the only thing you can do here is to factorize the expression. All right, so how do I factorize the expression? So we have, looking at everything here, there is a common factor. But before then, let's rewrite the expression so it doesn't look scary. All right, so rewriting these two, we have 15, then with these two brackets next to each other. Then bringing these two together, we have 2 brackets 3x minus 2 all raised to power 5. Okay, so we can now factorize. So by factorizing, you look at this carefully. By factorizing, something is common. You can see that this number in the bracket is common to them, but they have different powers. So I'm going to pick the lowest power. So the lowest power between 4 and 5 is 4. So I have to bring out 3x minus 2 raised to power 4 as a common factor. So bringing it out here, so the resultant, that is what we have left after factorizing, we are going to have 15 brackets 2x minus 1 left. Then remember, this is power of 5, but we have factorized power of 4, meaning that we still have one more power for the expression in the bracket. Okay, so I have 2 brackets 3x minus 2 left after factorizing 3x minus 2 raised to power 4. Okay, so let's simplify what we have inside this bracket. By simplifying what we have in the bracket, we have 15 multiplied by 2x, that's 30x. 15 multiplied by minus 1, minus 15. And 2 multiplied by 3x, 6x. 2 multiplied by minus 2, that is minus 4. And then bring down this common factor. Then you simplify everything we have here, and this the result. So the final answer of differentiating the expression there using product rule is this. I hope it is clear. We want to look at how to apply the quotient rule to solving questions. So here we have 2 questions. Differentiate with respect to x. The first expression is given to be this, and the second expression is given to be this. Remember, before you differentiate, sometimes you need to rewrite the expression where necessary so that you can differentiate easily. All right, now the solution to the first part of the question. We have y equals bracket 4x minus 5 close bracket raised to power 2 all over 2x squared. So remember what I told you about quotient rule. So quotient rule is just like you're having 2 expressions, u and v, and you are dividing them together. So when you have an expression like that in division form or fraction form, then you have to use quotient rule. But when you have expressions of u and v in product form, you are using product rule. All right, okay, so let's continue. So let u represent the numerator the expression on the numerator, and v represent the expression on the denominator. Alright, so differentiate u with respect to x. Remember the composite function I gave you. So you differentiate the entire expression and you differentiate the internal expression and multiply them together. So differentiating the external expression, I have 2 times invisible 1, which is 2. Then remove 1 from 2, that's power of 1. Alright, then differentiating what we have inside the brackets, that will just give us 4. So let's multiply them together. So 4 times 2, that's 8, leaving the bracket beside the 8. Okay, so that's very easy for composite function. Now let's differentiate v with respect to x. So dv dx gives us 4x. Do you remember? 2 times 2 is 4, then 1 minus 2 is 1. So that gives us 4x. Okay, now we can now plug in the values of those variables into the formula, the quotient rule formula. Alright, recall this is the formula for quotient rule. Okay, so let us plug in the values of each of the parameters and simplify. Please follow carefully. Alright, so the first thing we want to substitute in this formula is v, and v is given to be what? 2x. Then followed by du dx, which is given already to be 8 bracket 4x minus 5. Then the next thing we want to substitute is the parameter u, and u is given to be what? 4x minus 5 bracket square. And lastly, we have dv dx, which we have obtained to be what? 4x. So let's simplify. But remember, we have a value on the denominator, v squared. So v squared, what do we have for v? V is 2x raised power 2. So you square it, and that's this here. Alright, so let's do that one after the other. So 8 times 2 is 16. Can you see? Then with x squared, every other thing is still intact. Then 4, bringing 4 before the bracket, every other thing still remain intact. Now square of 2x squared, that will give us 4x raised power 4. Can you see from here to here? Alright, now the only thing we can do now is to factorize. So let's look out for the common factor. Now the common factor to these two terms on the numerator is 4x. You can see that 4x is common to 16x squared and 4x, abi? Then also this bracket is also common, but remember we have power of 2 here and power of 1, and I told you always take the lowest power, so I'm going to take power of 1, so alongside 4x. So the common factor here is what? 4x bracket 4x minus 5. That's the common factor. So let's divide. So when you divide this first term by the common factor, we'll be left with what? 4. Or by the time you multiply to open the bracket, you still have everything here. Alright, now when you divide the second term, everything here, by this common factor, we'll be left with what? Just bracket 4x minus 5. Okay, alright, then all over, we bring down the denominator. Now let's divide. You can see that 4x can divide. So when you divide 4x here, I'll be left with x raised power 3 at the denominator. 4x leaves the equation here, so I'm left with this entire bracket. So let's open this other bracket. Minus before this bracket changes the sign in the bracket, so that becomes 4x minus 4x plus 5. Okay, please take note of that. So 4x minus 4x, that's 0. That means 4x minus 4x becomes 0. I'm only left with 5, so 5, bringing 5 beside this bracket, so I have 5 bracket 4x minus 5 all over x raised power 3. So at this point, this is the simplest form, and that is the final answer for differentiating the first question using quotient rule. Okay, now let's take a look at how to solve the second question using quotient rule. So this is the second question, and that's the last question in this video for quotient rule. So we have y equals x squared minus 1 all over the square root of 2x minus 1. So we need to rewrite these expressions first, so we can use u and v to represent the numerator and denominators respectively. Alright, so let u represent the term on the numerator and v represent the term at the denominator. Remember, this square root sign changes to power of half. Every other thing remains the same. Okay, so du dx, let's differentiate this. when you differentiate this, we have 2x. Remember, 2 multiplies 1, then subtract 1 from the power. Okay, then let's differentiate this composite function. Remember, I've told you, let's differentiate the outer expression, everything all together. So half times 1, that's half. Then subtract 1 from 1 over 2. That gives us negative 1 over 2. Then when you differentiate what you have inside the brackets, that will be 2. Right? So multiply 2, that is the result of what you have in the bracket, times the result of what you have outside, everything after you have differentiated. So that will give us 2 times half bracket 2x minus 1 all raised power minus 1 over 2. Okay, so 2 crosses out 2. Okay, and we are left with this bracket raised power minus half. So that is the value of dv dx. So du dx and dv dx. So now we can plug in these values into the formula using quotient rule. So here is the quotient rule formula. So v is given to be what? This, and I written it here. Then du dx is given to be this, and you can see it here. Then minus u is this, and you can see it here. Then dv dx, that is what I have obtained here, right? So you just have to be very careful and pay extra attention, avoid errors or mistakes. Okay, all over, and then we have v square at denominator. So here's the value of v. So v square, that means the two powers multiply themselves. So power half times power 2 in the formula, that becomes power 1. All right, now when you simplify everything we have here, we'll have it as this. Look at it carefully. So 2x is coming forward, then everything still remains the same. Remember, half times 2 is 1, so everything here with invisible power of 1. All right, now so the only way we can solve and simplify this expression from this point is to multiply both the numerator and the denominator by 2x minus 1 all raised power half. So when you do that, you can simplify this expression as this. Then from this point, 2x times 2x, that gives us 4x squared, 2x times 1, 2x, then minus, open this bracket and change this to plus. Okay, then at the denominator we have 1 plus 1 over 2, that's 3 over 2. All right, so from this point, when you simplify further, you're going to have this. Okay, now recall, you can still write this as 3x squared minus 2x plus 1 all over 2x minus 1 raised to power 3 over 2. It's still the same thing. All right, okay, so here is just the answer to that question. I hope it is very clear. So if you have any question or further explanation to clarify any of the procedure, please drop your question, and I would give you a better and clear explanation. All right, so we are going to continue in the next video. All right, so in the next video we'll be looking at application of differentiation. So we'll be solving differentiation using the trigonometrical function and the logarithm function and some other aspect of differentiation. Okay, in the next video. Also, let's stay tuned for the video of the second part of calculus, which is integration. I will also drop it as soon as possible. I hope you love this video. If you do, please like this video, and you can also share with your friends. All right, see you next time.